This video tutorial is designed for students in New South Wales studying the Stage 6 Software Engineering Year 11 and 12 syllabus. This is for the content area Programming Fundamentals. Credits for some content in these slides go towards the Year 11 course textbook by Chandler et al., as well as James King's eForge Online. Syllabus dot points that we're covering today is really around structured algorithms and using pseudocode, including the use of what we're going to throw in here in USST subprograms or subroutines. We're going to look at specifically procedures and functions in these algorithms. So let's start off with the basics. What we're talking about here. We're going to start with subroutines. Subroutines are a specific block of code that performs a specific task. Now, at the moment, at this point in Programming Fundamentals, we have only been coding things that achieve one task. So we have only been coding single blocks of code. However, as we move through the unit and we start to get more diverse with our programming and get slightly more complex and we have multiple tasks, it's really important to ensure that we do something called modularize or split up our logic into specific tasks and keep those tasks in separate blocks of code. Not only does this make it easier to read, it also makes it easier to maintain and easier to test and easier to therefore modify. It's important to note at this point in time, if you start looking online, there's a couple of terms that will be used quite poorly and synonymously for the same thing. Subroutine, module, subprogram, sometimes even procedure, are often unfortunately used interchangeably to refer to the same thing. A simple block of code or selection of statements that performs a task. So any of these words are fine. I'm going to use subroutine for the moment, but all of these words will mean the same specific thing. In relation to subroutines, we are going to look at two particular types of subroutines. Now, like I said, a subroutine is just a set of code, but with these two that we're going to look at today, they have certain behaviors in terms of what they send back to the main program after they've performed their task and what can be passed into them. So the two things that we're going to look at are functions and procedures. And again, unfortunately, like we've just discovered, they're often used interchangeably and people will call a function a procedure and a procedure a function. But it's a point of note here that they are actually two different things. And where they differ is in terms of how they handle parameters and what they return to the main line of code. So first off, when we're talking about a function's a block of code that performs that task that we were talking about, that specific task, and it returns a value to the main line of code. It can take input parameters and then returns the output. A procedure is different. A procedure is a block of code that performs a specific task, but it doesn't return a value. So simply in my main line of code, I call the procedure and it executes that, but it doesn't allow for any particular input parameters or anything to go through it. It just simply executes the procedure. The example here we have in Python, this example is a function. So in Python, when we wish to make our own functions, which you will be doing today, so not call a function like print or input or int, if we want to make our own function, what we have to do is we have to use the def keyword, and this is defining. This defines this subroutine or defines, in this case, this function with the def keyword. Immediately after the def keyword is the name of my function. Again, kind of like variable naming, it doesn't really matter what I call it, but I wish to call my function something indicative of what it does. So at this point in time, we're actually using an example to calculate the square of a number. So I'm going to call it calculate_square. Reminder, no spaces. Pick your horse if you want to use underscores, if you want to use title case, it doesn't matter, be consistent in what you do, however. Then in the brackets immediately after that is the parameter that you want to pass in. Think of the parameters naming type like variable naming types. Obviously, it can be anything. You don't have to assign it a value initially. It's simply a parameter, but you also want it to be slightly indicative of the types of data or the types of parameter it's wishing to take in as an input. If you're looking to calculate a square of the number, obviously the parameter you're passing in is the number. So it's hence good to name that parameter number. Then here, in order to send an answer, send a value back to the main line of code, it simply hits return number times number. You can have many lines before you return, up to you. This is a pretty simple one. So in order to calculate the square, it's the number times the number, and that's what I'm returning. That there, those two lines, That's the subroutine. That's the function because it's returning a value and passing a parameter in. I then, in the main line of code, in a separate section, then call that subroutine. So that's the SST. When I want to use it, I then call that subroutine. So I create a variable here, and I call it result, yeah, equals calculate square. So this is me calling this calculate square function. I am passing in a parameter. If there was documentation for my function that I've made here, I would have to tell the user it requires one parameter, it's mandatory. That parameter is a number, the number can be, and then I can give it a range. Obviously, we're just making a basic one here, so we don't have to document what we're doing, but we can kind of get the idea of what's going on. One parameter number, in this case, I'm going to pass 5. What would that look like? Well, the second line of code in the main line, sorry, this is actually a line of code. I know it's not highlighted in yellow, but this is the second line in second line of code in the main line. I then go print, the square of 5 is, and then I pass in that variable called result. That will then print to the screen. If I just had this line here, it would do the calculation, but because it's not feeding anything back to the user, it would look like nothing is happening. And I've actually gone on in these slides to explain exactly what I've just done there, returning the result and the output. So just a couple of points of note there. Obviously, this is the function, this is then calling it, and this is then printing the result. These two here, this line and this, are counted as the main line. I did want to just make a note that example with the square of a number was only taking in one parameter. I can actually take in multiple parameters. So a calculate area function, so calculate area rather than a square, requires 2 parameters. To calculate the area of something, it's a length and a width. These 2 parameters can then be passed in, like the subroutine can be defined having multiple parameters, not just one parameter like this one did. And you can also pass multiple arguments in the main line in order to be able to feed them in. So I suppose a differing point of note here in terms of SST, these are called parameters within the context of the function, but when I'm trying to assign a value, and this line here, when I'm actually trying to then say, okay, I want to pass this value of 5 as a parameter here, and I want to pass this value of 10 as a parameter here. In this instance, it's called calling the subroutine with arguments. So they're called arguments here when I'm calling them in the main line. When they exist within the function, a point of note is that they are called parameters. So a couple of tricky things there at the end, arguments v parameters. You can write functions with multiple parameters, obviously, and we will get into a bit of stuff with procedures next lesson. Thanks, guys.